Good afternoon, everybody. Good morning, good evening, for what place you are locally. At this stage, it's 1 o'clock in Amsterdam. Welcome at the Amsterdam International Water Week to the webinar, focusing on the real-time driven pathways for the robust water system, the critical role for utilities and its benefits that could appear. I think we have three very interesting, excellent speakers for the next session for 45 minutes. My name is Rick Thijssen. I'm working at Vitens Water Utility here in the Netherlands, taking care of almost 6 million customers. I'm the moderator of this session, and I would like to invite you to send all the questions in the Q&A, and I will try to grab 1 or 2 questions every session. And I will first want to introduce to you Abel Hensbroek, who's a colleague of mine from Vitens. Abel holds a Master of Science in Water Management from Delft University, and he is responsible as a process engineer for very complex innovation programs. And one of the initiatives he's going to share with us for the next 8 to 10 minutes. Abel, go ahead.
Right, thank you, Rick, for the introduction. First slide, please. Yes, thank you. Well, good morning, afternoon, or good night, everybody who's joining. I'll tell you today something about the work we do towards intelligent treatment plants, something we call the SLIM project. Next slide, please. Yes, so let me tell you a very quick introduction about Vitens. At Vitens, we are the largest drinking water company in the Netherlands. We supply over a third of the company of the country, and we do that with 92 treatment plants, together supplying 350 million cubic meters of drinking water every year. Given our location in the eastern part of the Netherlands, we only use at this moment groundwater and riverbank filtrate, and because we use groundwater and these kind of sources, we see a very big variety in treatment intensity and a very big variety in treatment processes. So, for example, in the middle part of the country, we have very simple treatment plants, maybe only utilizing a simple sand filter. And in the northern part of Friesland, we have very, very complex treatment plants who are more akin to chemical plants with a dozen treatment steps. So a very big difference between operation in every region. Next slide, please. If we look at our water treatment system, we can identify 2 main operational challenges going forward. We see that in the coming years, in 10 years' time, we see that more than 40% of our current process operators will retire. Well, those are men that have been working for our company for sometimes over 30 years and have very, very intricate knowledge of the systems we have. They retire, and we have a very hard time replacing them with enough new operators. So how do we retain their knowledge? That's a very big operational challenge we face. Second operational challenge we can identify is that we try to optimize and control our treatment plants using lab measurements only. And lab measurements are obviously perfect for giving water quality data, but they are marked by 2 problems. First, you have a very relatively low sampling frequency. So for some of our treatment processes only get sampled once every week or even every month, which gives you a very limited insight in how they are functioning. And furthermore, there's a very large delay between sampling and result. By the time the sample has been taken, has been sent to our laboratory, the water, and we get the result back, the water has already been consumed by our customer. So by the time that we find out something is off, we are already too late. Next slide, please. So to overcome those main issues, we are working on a Vitens digital strategy, where we have the main goal to transition from an experience towards a data-driven operation. And that means that we can reduce our reliance on these scarce operating experience because we try to capture the knowledge in our data-driven systems. It also helps us to better understand and monitor our system performance and helps us identify optimization potential. However, the big issue with this, with a new digital strategy, is that we really need a lot of real-time data to achieve this. Next slide, please. So how do we get this real-time data? So this could be a solution. We could obviously install hundreds, thousands of special-made quality sensors in our treatment plants. And this could obviously work and would supply us with a lot of real-time data. However, remember that we have 92 treatment plants. We have over 1,000 sand filters. Equipping all of them with specialized sensors would be a very, very expensive and very complex operation, just to install and buy the sensors, but also to maintain and calibrate them. Therefore, we have developed a different approach. Next slide, please. We call it a digital twin-based solution, where we augment the existing sensors that we have with simulation models of the treatment processes in the treatment plant. So, for example, a simulation model of a well field, a simulation model of a clear water pumping station, and a simulation model of a sand filter. And together they form a digital twin of our treatment plant. Next slide, please. So we call this system the SLIM system. We've been developing it fully in-house, and we have it in operation since 2016. And it's good to mention that we only use open source components. We want to share the knowledge and experience we have freely with other water companies. Since 2016, we've been working on it, and we've embedded it really in daily operations. So a lot of operators in the field use these systems in their day-to-day work. And this system allows us for real-time digital-based monitoring and optimization. Next slide, please. So these are the main components of the SLIM system, and central of it is the SLIM database, where we aggregate all kinds of data from our existing systems. We get the process data, we get all the asset information, we get the lab results, and all this data combined we feed to our digital twins, who report back to the SLIM database. And the SLIM database can then be used for either advanced analytics or for operator dashboardings. Next slide, please. So here's a very quick example of how this SLIM database looks like. We've built a hierarchical database with all our treatment processes, all our components, and have coupled all our data systems together. So here you can see a well, and we can instantly get the data from the last lab measurement. Next slide, please. Here you see an example of a digital twin. This is software we've developed in-house and allows us to follow water quality from our well, which you can see on the left, all the way through all the different treatment processes to the clear water storage all the way on the right. And in every block you see is a simulation model that predicts water quality based on process settings. Next slide, please. What we see is that we've through years of development have been able to make these models, these digital twins, very accurate in predicting the water quality that we produce at those plants. So here you can see the blue lines is the model predicted value, and the orange dots are the lab measurements. And what you can see is that we can really we can tell the data during normal operation, but also during unexpected events where you can see spikes in the data. We capture those as well. Next slide, please. To couple this data back, we have developed a dashboard. We call it the SLIM dashboard, where we give operators feedback directly based on the digital twins. So as soon as they change the setting in their physical plant, they can look at the dashboard and see on these gauges how their performance of the process is. Next slide, please. And they can even see it on their mobile phone. Next slide. So what's the outlook of our system? Remember, we have 92 treatment plants. So far, we have 40 of these digital twins up and running and in lockstep with real-time operation. We've seen a marked reduction in quality standard exceedance and also a faster lead time and response time when we do identify an issue. We're also looking at using these digital twins for training new operators, but also for offline optimization. So we can make changes, physical changes to a treatment plant without having to do them in practice. We can change plant operation, control schemes, or dosing regimes without disturbing the actual water quality. And we are further developing modules for energy and chemical consumption monitoring to further augment our system. Next slide, please. That was my presentation. So back to you, Rick.
Abel, thank you for sharing with us and the audience the result of the SLIM initiative, what initially started in 2016. I'm looking at the Q&A and I'm well informed there is no current question raised in the Q&A. Let's have a check. In the meantime, I will leave one question with you. You were referring to one of your sentences about, you were talking about the unexpected events, which is with its part of the solution shown with SLIM. I can imagine that are also, let's say, there was an unexpected impact of this development on, by example, on the operations staff working within Vitens. Can you share some experiences with the audience?
Well, one of the transitions we've made with help of the system is reduce the amount of operators working on quality. So in normal operation, we would have one operator per treatment plant, and now we see one operator checking and monitoring maybe up to 5 or 6 or even 10 different treatment plants. So we see that this system helps them monitor their system.
Okay, thank you, Abel. I've checked the Q&A, no questions so far in the Q&A, but I will keep an eye on that. Then it's time to move to the second speaker, who is Andy Smith from Anglia Water. Andy is an esteemed colleague from us already for a couple of years. Andy is Smart Water Strategy Manager within Anglia, and he's going to share with us a project which is showing the value of data and making use of artificial intelligence. Andy, it's up for you.
Thank you. Hi, everyone. Nice to meet online with all of you from around the world. I'm going to talk to you, and it's very similar to the work that Vitens have been doing around an AI project that we've been doing at one of our works within Anglia. So the project focuses on 2 works. They're actually at the same location. So one of the works was built in the 1960s, and then the extension was built in the 2000s. They're both fed by surface water abstraction. Treatment is through rapid gravity filters, and together they treat and distribute around 250 megalitres of water a day, with an average cost of around £1.5 million per annum. This can increase dramatically depending on obviously the quality of the water entering the works to a top end of around 3 million. So you can see why we need to sort of drive some different solutions in that space. Costs are very driven around chemical, so ferric dose and poly makeup, ozone control. And then the other area that we would traditionally focus in is around the power consumption of that unit. Next slide, please. So the project will actually enable new experiences in the way we interact with the process of turning data into information through combining algorithms, real-time data, and visualization. Data fusion can also happen in the world of visualization tooling as well. Transforming how we see things will inspire new ways of thinking, transform the way we invest, and supports our strategic, operational, and tactical decisions being made at any point in time. The system visualization aspect and learning how those systems are being operated, controlled, and managed will then support our challenge of identifying, prioritizing, and monitoring our strategic and critical assets. So we're doing a lot of work with regards to condition-based monitoring at the same works as well. And hopefully developing this learning will move us into a prescriptive phase where systems will identify areas of concern before they turn into problems for our customers or the environment. Next slide, please. So as you can see, we started on this journey, and I was just talking to Rick before we started the presentation, was we needed to jump on at some point. You know, with regards to AI, it's very new within the water industry. So we decided we would jump on. And what did we know at the time? So these sites are manned 24 hours a day because they are part of the critical national infrastructure of the UK because it's such a large work. And we knew we had data captured solely on site using various PLCs, HMIs, and data capture forms. We had energy data, which was being captured through power loggers, and we assigned that as high value data as part of this process. We knew we had flow of water through various treatment processes that could be measured. So yet again, a high value data stream. And we had some data around chemical dosing, which yet again was high value. Operational site costs were interesting to say the least when we started to drive and dig down. We also then found out that, for instance, we had 3 schematics of the same site and depending on who had what. So there's this whole opportunity to start to look at the data and understand the value of the data that we were driving from this process. From an architectural point of view, we had near real-time data transfer using 15-minute pull cycles, and we had 3 live assets and trend tags that we could actually connect to on that site as part of the process. Next slide, please. So what we actually found then was that we had quite a lot of data that was actually captured solely on site. It's very high value, but very difficult to integrate. So one of the things we developed as part of it was we developed our own Power Apps, which was developed to capture the data required and digital transformation of old paper copies, which were being stored. The energy loggers, we found that not all of those energy loggers provided the accuracy that we required. And there was a variance in that accuracy as well. Our water flow meters were high value, but the quality was poor in some areas, and I'll come on to that in the next slide. Chemical dosing, high value data again, but very difficult to integrate in our existing systems. So we developed new Power Apps in that space as well, and we digitally transformed from old paper copies using the Power Apps. Our operational site costs, so the value of that data actually started to reduce as we were building the models, and the accuracy of the models increased, and we actually established new baselines, which was very important for us. So if we want to move to the next slide, please. And this is an interesting slide. So what you can see on here is, this is an example of some of the data gaps that we actually found while developing, curating the data models. So the point was there is understanding the accuracy of those predictive models based on that data. And there were some data or some data streams that were missing, which we actually didn't understand as a business why that was. And after simple checks, we brought them back on. So this is all about really starting to understand the value of data. We're very good within the industry of valuing the asset, but actually the data that's associated with that asset, I would say there's still a lot of a journey to go on. So we can move to the next slide. You can start to see some examples of the machine learning that's been taking place to ensure the accuracy of the models, and the models are continually learning as the data is ingested. And what you can see in the top graph is a good example showing the model has learned to predict. So, you know, the blue line is the actual data, and then the orange line is the predicted. But actually, you can also see where we've got another model on the bottom, which is a poor example where you can see the model has not learned to predict. So then what we need to do is then further investigate the data quality, whether it be the sensors that are actually out, and then actually refresh that and then get the model to learn again. If you can move to the next slide, please. And as we've said, the models continually learn as the data is ingested into the system. And below, the model has learned to predict and was very, very accurate. But as you can see, if you lose a signal or a particular data stream, actually you get to a point where it's inaccurate, and then the prediction actually goes offline, and then you have to wait till that sensor or whatever comes in. So it really starts to think about what things you need to maintain within your process. So actually the instruments become just as important as the physical assets because they're driving the efficiency. So if you want to go to the next slide, please. And with regards to the example here, these are the demand models prediction. And as you can see, we went through some very interesting phases. So the models are learning to predict the outlet flows from the reservoirs. So we've linked the treatment plant to the outlet flows of the reservoirs. And as you can see, we've started to match that very well now over a period of time. And if we go to the next slide, you can start to see here, there are multiple zones downstream of these 2 treatment works. And actually what we're getting to is a really good pattern of actually understanding those flows within those distribution zones and accurately starting to do that. Now, this has taken about 18 months to get very, very accurate in terms of the data that's being ingested and understanding how that system as a whole is performing. If you go to the next slide, please. And then yet again, another example when we're looking at the levels and the pumping times, and the models are reasonably accurate in this case, but we need to still understand some issues around some of the level data and that sort of latency in terms of the data that was talked about. So traditionally being 15-minute data, we need to improve our latency of our data in terms of how we drive things forward. So when you look at how we're moving, so there's 90 models as part of this. We're at 88% of that, and we're now in the final stages of validating those final 11 models, and they will now start to monitor and learn how the process operates. A continual piece of work around final data cleansing actions, and then also now the biggest part of this is really how we engage with our workforce. So the engagement sessions are now starting, and what we're trying to do is drive an efficiency target of around 6% reduction in chemical and energy costs as we stand at the moment. That equates to around £200,000 a year in terms of efficiency, so no small amount of money. We've recently had business cases approved to install additional instruments to support the machine learning, you know, really looking at the quality of the water coming in, because obviously at some points we have been over treating, and then at other points we've been under treating. So in conclusion, the project has actually helped us understand the value of the data, how we turn that data into information to operate as our systems optimally and for our customer and environmental benefit. Also how we engage with our workforce to ensure that the technology is embraced and that all the changes we make in terms of optimization are sustainable going forward. And then something that we found, even on the newer works, which we thought would have a number of instruments on, which didn't, is how using this AI and understanding the data requirements actually moves us towards changing our processes and standards. So when you look at our minimum asset standards, how do they need to change to maximize the use of data-driven technologies? Thanks very much.
Andy, thank you very much for this very clear presentation you just showed all of us. I see there's one question from Ruby Neervoort. He would be from the Netherlands or from Belgium, I assume. And the question is, if 18 months of development is the average for an AI system to learn and to predict as a tool?
I would say not. I mean, I think this is that whole sort of inception for us. So a major part of where we started was actually creating the models and actually realizing how poor some of our data streams were. You know, traditionally we would look at optimization of a single part of that process. So we were very good, for instance, at energy monitoring and driving energy costs down. Then we would look at a certain part of the process. What we're saying with this piece is that we're driving that extra 4 to 6% by looking at the whole system and how it interacts with the distribution system. It brought us challenges, particularly around things like flow meters in the distribution system and validating that data. I think when you look at it, it's probably about 3 months worth of data validation once you're happy with the data quality coming in. But I think our learning would be that we would probably start looking at our sites before we implemented the AI with regards to data cleansing well before we actually implemented the AI. So we could shorten that period down quite considerably going forward.
Thank you, Andy. I have one question in addition to your explanation. Earlier this morning, there was at the Innovation Forum here in Amsterdam Live, there was a session moderated by Dragan Savic. And one of the topics was a discussion if artificial intelligence in the water industry is a hype, yes or no. And the answer was something like 65% of the audience was saying yes. What is your view on that related with the fantastic work we have seen from your side, but also from the work from Abel so far?
I think we have to go there. We no longer have the privilege of doing a 30-year apprenticeship with regards to our guys on site. So, you know, we're in the same position as you with an aging workforce. I think as a training tool and not having to go through 10 years of experience before you become a senior operator. And, you know, what we will see is knowledge will leave our business. Actually, a part of this process is to bring the knowledge of those people into these systems as well. So I don't believe it is hype. I think You need to understand where AI can play for us. It's probably not everywhere, but when we're looking at treatment plant optimization, I think AI has a really important part to play going forward.
Thank you, Andy. Then I would like to propose to go to the third speaker, and apologies to Amrita that ladies finished, but I think it would be a great finish. I would like to introduce Amrita Gautam. She is a doctoral candidate, project lead at the Technical University in Germany, in Cologne, but she has origin in Nepal. I would like to advise everybody to have a look at her LinkedIn, which is very impressive on such a young age. So please have a look, and I would like to give Amrita the opportunity to share her presentation on empowering use and supporting utilities through data-driven engagements. Amrita, up to you.
Thank you so much, Rick, for this great introduction. Thanks everyone in the organizing committee of Amsterdam International Water Week and this session, and all participants for this wonderful opportunity and support. Today, as Rick has already mentioned, I'm going to present about the context of my ongoing doctoral research, where the development of suitable model and empowering citizens and supporting utilities through data-driven engagements with youth at the central role, and ICTs, information and communication technologies, as the main tool to enhance drinking water security in the local areas. So the case study area is Pokhara Metropolitan City in Nepal. Actually, this is a bit of different approach than the previous ones. The colleagues have already explained a very advanced level of digitization in water supply schemes. But in our case, because we still have a lot to do, we still need to approach in a different scale right from the beginning to reach fully digitized system in water supply schemes, where we are still struggling for basic information on water supply and quality in general. So we are in, as I already said, in preliminary stage, initial stage of acquiring real-time data by empowering citizens on the ground, thus supporting local water utilities. Next slide. As we all know, safe drinking water and basic sanitation facilities are essential for human civilization. And we also know that not everyone in this world is able to receive these facilities. According to Joint Monitoring Program 2017, only about 5.2 billion people use safely drinking water services in 2015, and the developing country like Nepal is in between 26 to 50% in proportion of population using safely managed drinking water services in the same year. In addition, the same report also indicates about 2.4 billion are still using unimproved sanitation facilities, especially in the developing countries, resulting, we know, the linkage of more than 80% of illness to these issues. Next slide. And we also know how important and crucial the relation between water and public health. In this graph, in left side, shows the proportion of population using unimproved source and the case of E. coli detection in the developing countries like Bangladesh, Nepal, Ghana, and Congo. Referring to the Nepal data, it explains 91% of the population has got access to improved source, and more than 70% of percentage of the population has got access to the improved source, but with E. coli detection. This indicates the need of proper monitoring mechanism in its place. The second graph shows that about 2.2 million people die from diarrhea each year, where 90% of those deaths are of children, mostly from developing countries. In the context of Nepal, about 44,000 children die every year under the age of 5, with the lack of safe drinking water and poor sanitation situation. Next slide. And out of all these issues I just mentioned, several questions come ahead, and the important question for me and my research team has been, do we have regulation in drinking water quality monitoring mechanism? And this actually directs to me the several other questions that I'm dealing with my team. Are we able to involve youth at the center of monitoring initiatives? Does it really support? And what about the suitable design for the involvement? And how about the real-time data accuracy, reliability, and sustainability aspect of the model? Because it is always the big question when we talk about citizens' involvement, citizen science. And how about utilizing the knowledge of local women in this process? Yeah, how do we involve, how do we ensure the gender, like equal gender involvement? How do we ensure inclusiveness in this process as well? And how about important factors for long-term support? And last but not the least, how about climate resilience and adaptation, including the emergency response and crisis management? So these are the questions posing every time us to motivate to do the things that we've been doing in the field. Yes, as I have been saying, there is a lot to do, and there are several things that make us frustrated while working in the field, but it is also very empowering and motivating and very rewarding when it comes to working with local citizens, because it is not just about the one-time work that we are doing. We're actually developing, and we're actually trying to save the future that can actually help us for the long term, and also give us so much of learning ahead. So next slide. And this actually it also shows it also explain about the case study area, Pokhara Metropolitan City. I think some of you here in the audience have also gone to Nepal and have known about the Pokhara Metropolitan City, and these like there are the two water supply schemes we are working with at the moment as the pilot case study. So yeah, when working in this doctoral research, I came with the decision to found an initiative called Drink Pani. This is the research-based initiative, and it intends to bridge the gap between water utilities and communities in information flow on water supply and quality, with youth as key actors and ICTs as the main tool to navigate the path to reach policymakers for evidence-informed decision-making. Therefore, leveraging the capacity of youth in smart water from local grassroots initiatives to the global impact is the must. And for me, conducting doctoral research and publishing a paper is not the ultimate motive. I want to see the beyond. I want to see what after it. Like, I want to see the real impact that our research can do in the ground, so that we can help policy making. We can help. How do we connect our work in science, policy making, and thus support the sustainable development in the areas that we work. And next, and it also actually explains about the methodology, but due to the time limit, I cannot explain everything. But if you have any question about the methodology, we can also.
Hoi Sander. Hoi Quirin, zijn we weer.
And the important part is the youth-led.
Oh ja, ik had een vraag aan jou.
The youth-led participatory sensing model is the support in surveillance monitoring, where water utilities lack the sufficient and active manpower for regular monitoring. So given the tools and equipment to test and share water supply, sanitation, and quality monitoring data for effective communication flow, which is not happening. Next slide.
Oké, stuur er maar door inderdaad. En
hebben jullie dezelfde setting als de vorige sessie?
Ja,
Want het geluid was
Next slide.
Apologies, Amrita, we have a technical issue, I think. Give us a few seconds.
Of een externe microfoon. Heb je ook mijn andere collega nu in beeld of niet?
Nee. Wie is jouw andere collega? Misschien ik even vragen.
Ik weet niet van welke laptop ze het doen. Darja, zie je die? Zit Darja ertussen als...
Amrita, please give us a few seconds. We are managing the issue.
Okay, that's fine.
Let me check hierin with what name? Of
Yeah, I was actually explaining about the youth-led participatory sensing model to support in surveillance monitoring, where utilities lack the sufficient and active manpower for regular monitoring. though given the tools and equipment to test and share water supply and sanitation quality monitoring data for effective communication flow, which is actually not happening in regular process. And I'm waiting for the next slide. What technical issue will be solved soon? Yes, now it's solved. Thank you. And so can I go forward, Rick? Yes. Yeah, okay. Then,
yes, you can, Amrita.
thank you. So here comes the topics about the digital
Ja, komt eraan, Judy.
digital tools,
even kijken.
fieldwork, and initial outcomes.
The
We
name should
launched,
be Daria. Of ja, je moet Daria toevoegen.
we have launched our own mobile app and website, Drink Pani.
Ik ga even
It reflects the continuous iteration process more than a year. Yeah, it reflects, we have launched our own mobile app and website, Drink Pani. It reflects the continuous iteration process more than a year, almost 2 years, with users and advisors to come to this point. We know water works in the first line of defense for healthy living, and Drink Pani believes in shaping digital future. In this initiative, youth as the key actors, as young water volunteers assigned officially in water clubs with intensive training and tools for water sampling, tests, data collection, reporting, and sharing.
Okay, nice. Can you guys hear
Under
me nice and clear?
youth-led participatory model in
Is there
progress.
any background noise or small sounds or anything?
For the pilot study, 2 schools named Janapur Higher Secondary School and Gurukul Vidyashram were chosen to cover the area of 2 selected water supply schemes of Pokhara Metropolitan City. The graphic of initial results shows here the variation in water quality index and the temporal variation of parameters pH, EC, resal chlorine, total hardness, and E. coli in Siswak with the area of Leknath water supply scheme Pokhara. So now with the regular workshops, seminars, and training sessions, including direct consultations with water utilities, all the stakeholders and advisors, young water volunteers tend to support in climate-resilient water safety plan for the respective water supply schemes. Thus, it is always valid. Youth are the leaders of today and tomorrow. In any context, children and youth today are the ones who will be taking the charge of the high-level policy making and implementation in their own communities to the global scale. So we need to start involving them practically since their early age. We do believe it is vital to infuse right skills and practical knowledge of theoretical background to young minds, which enable them to think critically and motivate them to solve their life problems with challenging mindset. It also helps them to understand the importance of research-based learning and encourage them to grow as volunteers for the good and responsible professionals in water sector and beyond. Digitization and smart technologies are undoubtedly our future in management and assuring sustainability. And as I said already, the capacity building process with knowledge and practice of right tools and methods is vital for sustainable growth and development.
Maybe if you unplug and plug in, maybe sometimes it works for me. Delete the.
First of all, Amrita, apologies for the disturbing background noises from, I assume, the control room of this digital event. Really apologies to you and the audience. I see the chat, so it's a little bit frustrating for everybody. Compliments for you pushing the presentation, and you were for sure able to overrun and overshout everybody, but sincere apologies to you that this was happening. I think it's now finished, but it's still not perfect. So let's try, based on at least the main part of your presentation, which is showing us, let's start with the urgent need in terms of drinking water illness related and people dying from drinking water is still extremely important global issue. I think that's the basic start you make. My question, based on what you have presented, where data and digital, community, women, young people are basically your citizen science part, is what was the actual number of people involved from the citizen science part? How many people were directly linked to this project? To have a little bit feeling about the size and what does it mean if you want to create additional impact for the long term?
Thank you so much, Rick, for the very important question. Yeah, due to the time limit, I couldn't explain the model of youth involvement in this process. I'm about to publish related papers in some time. So I'll explain that. A very short note. Initially, when I had to select the schools for pilot project and young water volunteers, I went to different schools for like initial survey, and then finally I selected 2 pilot schools. One to look after the big water supply scheme that is contributing for more than 18 local administrative units, and another is around 8 administrative units. And in the bigger area coverage, actually in both schools we selected about 80 students. In the first batch, like 40 students, in total 80, and then we made some kind of analysis, and we selected 20 students in both schools and gave them training. And right now about 40 students from the beginning, and some more students were interested in the process. So we are about 45 students in the regular process. But to be honest, you can understand the citizen science process, volunteering work can be challenging when we are working in a long-term process, and also about the pandemic issue. So there are active students, about 20 to 25 students are working actively, and they are in a very regular communication with us in our research team. Thank you.
Okay, Amita, thank you for this extra information so far. I just check if there are questions left so far at this stage. Some questions. The previous question was by email or by app, which is not the case. And now, to be honest, yes, I received the confirmation. There are no questions in the Q&A so far. I'm not sure if the other speakers, Abel or Andy, has an additional question for you. Let's check if there's a question appearing from both of them. I don't think so. Nothing is moving. Amrita, again, apologies for the technical issue halfway your presentation. There's Andy.
Hi, Amrita. Yeah, absolutely fascinating what I could glean from it, and I'd really like to catch up because I'm doing some work in Nepal as well, down in Sirahar district in Laham with water aid. So how this is tying obviously in with the WASH program in country, yeah? Oh, sorry, you're on mute, Amrita, now.
Yeah, and actually I'm glad to hear from you, because I came to know about Anglian water work in together with Water Aid in Lahan district, and I have been in communication with Kavindra Purasaini. Actually, he's one of my seniors while I work in WHO Nepal before I came to Germany. So what was your question? Sorry, I didn't hear the last part.
Yeah, I'm sort of looking at the graphics. So I'm assuming the work that you're doing, obviously, around schools is very important, because obviously it's part of the sort of like WASH program in Nepal as well. And have you got government support in terms of the work that you're actually doing there?
Yeah, actually, when I worked in the WHO project in water safety plan before I came to Germany, I already had that kind of network and understanding in a Department of Water Supply and Sewerage. So one of my local advisor in Nepal is from WHO. His name is Sudan Rajpanthi, and they work closely with Department of Water Supply and Sewerage. And I've been also consulting the central laboratory inside the Department of Water Supply and Sewerage. As you know, it is under Ministry of Water Supply, and I'm consulting the water quality department of that. Water quality section of that department, and trying my best to interact them in a regular basis. But to be so honest, due to pandemic, it has been more than 2 years I could not travel to Nepal.
Yeah.
So this has been kind of a frustration to me to push the work in a very efficient way in the local level. But despite all the challenges, I can struggle at the hardest, but I will not give up. That's how I've been trying to work in a digital format and coordinating from here. And I would be so glad to talk to you and other Anglian water team like in the background later on, so that we can talk. Actually, Kavindra sir also talked to me and asked me if there is any collaboration opportunity in Lahan that we can do. And actually, I have been also asking him and all other professionals in Anglian Water that we can share our experiences and work support in our areas that we do. So that would be great to share our
I mean, your app looks fantastic, and I'm just wondering, what are your next steps?
Yeah, our next step is actually we are now in a pilot phase, and we are checking regularly the application, and we are trying to update our mobile for sure the mobile application and also the website, so that we can accommodate and display very relevant, transparent information. And we are in process to communicate with the department of the government agency, where they are also trying to compile the digital information. And I am looking forward to communicate with them so that our work can be actually integrated in the mainstream data communication process. So let's see how does it go, but I'm really optimistic, and I think it may take some time. But when we empower the local people in the ground, we know for sure that because whatever we do in water utilities, the local people are the ones who will be benefited, and we need to take care of them to have very close communication. So we will keep continuing with our vision, and I will keep updated also with the publication. Actually, my publications are coming up in a row, so I'll be in communication with you to explain more in detail, because right now with the time limit, I might not justify the explanation.
Brilliant.
Yeah.
Thank you for your explanation, Amrita. Thank you, Andy, for the discussion, which is very important. I've seen there's one additional question, but we are going to manage it in a different way, from Alejandra Guiteres, but we will handle it directly to you, Amrita. I would like to thank Abel, Andy, and Amrita for their contribution for this webinar today, and we look forward to meet you any moment, anywhere. Thank you so far. Have a nice day and enjoy the event. Thank you.